Okay, sorry guys, bit late tonight. Think I'd clean up my act for the last spotlight of the semester. I had a lot of trash to take down. Tonight's the trash night, and we forgot to do the recycler last time, and they come twice a month, and with all the Christmas boxes and Amazon boxes and move-in boxes, it was more trips than what I can remember. Um, So I apologize, a couple minutes late and had to get my act together. So looks like we got a good crowd for the kind of like pulling up the caboose for the spotlight sessions for the semester. So that's great. I figured a lot of people will be checking out, but thank you guys for making time tonight. Hopefully we have a lot to talk about. Um, and it seems like we got some folks we haven't seen in a while, which is always helpful too. Um, so what I've been doing probably since Thanksgiving is that I've been kind of um, well, so let's see. Excuse me. I'm gonna try to mute that phone real quick. Make sure this is something I don't need to talk to. Hold on, guys. 1 second. Sorry. Hey. Sorry, guys. That was somebody who their son just got diagnosed with COVID, and they don't know if they're going to be able to make it into work tomorrow. And I knew that was something I had to take. So my thing is, if you get diagnosed with COVID, obviously you'll be in quarantine. But if your son or daughter gets diagnosed with it, and you've either been exposed to them or whatever, I'd like to know how that works. And I think employee health will tell you to come to work and to monitor your symptoms. I think you come to work. That's how that goes. Um, anyway, it's not something we have to talk about tonight. I've wasted enough time. Yeah, yeah. Well, I hope you're feeling better, Jan. I just got I've been trying to avoid it as much as I can. I got the booster right before Thanksgiving, hoping that I got the first vaccine probably right after it came out. Um, I was eligible to get it because I do the testing for COVID. I work in microbiology, and that was a that was a surprise being 32 years of age and being one of the first primary people to get the vaccine. Yeah, yeah, I bet so. I know some people get their smell back, some people struggle with their smell, but Lauren, I'm sure you understand too. And it's just ongoing. So when you lead a group of people, you kind of have to figure out what the HR policies are, what the employee health policies are, so you don't expose everybody to COVID. I just told one of my colleagues to call employee health and see what the latest guidelines are. I don't know, and obviously I'm busy right now. Um, you know, she can look it up. She's pretty independent. I hope she can come to work tomorrow because I don't have anybody to cover her. So, um, crazy. So, guys, what we've been doing since Thanksgiving. Uh, yeah, I hope so, Jan. I hope you do. You know, it's time you get your life back. It's been 3 weeks for you. Um, what we really need to be doing is I've been doing review. Okay, we've been doing different subjects, different topics of review, and I've kind of opened it up to the floor on what we want to discuss. Now, obviously, I can bring up some points, and you will say, "Yeah, let's go over that," or "No, let's not." Oh, cranial nerves. Okay, we can do. All right. I know the big ones. I know, and the reason why I don't know all of them because it's not something that we focus on a lot. Vagus nerve carries out the parasympathetic nervous system. Okay, the vagus nerve is one that calms the heart, helps dilate the blood vessels, lowers the respiratory rate. The thing about vagus nerve is that when people who have heart transplants, they actually cut out the vagus nerve. So a lot of these people have to like take drugs to create the parasympathetic effect, right? Because that vagus nerve is gone, and that's the most interesting part right there. Um, so with that being said, that is something that we want to focus on is the vagus nerve. The glossopharyngeal, okay, right, runs right through here, antedates the jawline and maybe some of the lips. That's another one I've seen. Optic nerve. The optic nerve runs from your eyes all the way back, crosses into the optic chiasm. That's the optic chiasm that it crosses. If you have if you have a heart transplant, a heart transplant, a heart transplant, they will cut out the vagus nerve. They can't. It's within the heart tissue. So when you cut out the heart, it'll come out with it. Hope that makes sense. So glossopharyngeal, optic nerve, vagus nerve, those are the big ones. Okay. Cochlear nerve with the hearing. So the point that I'm trying to make is that a lot of these are Quizlet deals. Okay. Now you may have to. I don't know if you'll be able to memorize the numbers, like the cranial nerves. Like there's 13 of them. I mean, I don't see that. I don't put that on my test, but I can't speak for everybody. But if you really want to learn them and you feel better, I would recommend going over the cranial nerves. Okay. Quizlet, the cranial nerve Quizlet. I'm sure there's many of them out there. You all probably have studied them. If you can't find a Quizlet, make your own flashcards. But I wouldn't spend too much time on it because I don't think it's going to be a big one. It's not going to be a big one. Any other questions, concepts? I mean, before I go into my spill, maybe you guys want to take this spotlight another direction. Yeah, Cassie, definitely. Okay, Lauren said the same thing. So yeah, so this is what I recommend. And like I said, I'm not your instructor. Okay, so don't take this as just, happenstance. But here's the big stuff. Action potential. Okay, action potential, depolarization, repolarization, hyperpolarization. Sodium comes in, potassium goes out. That's a depolarization, right? Action potentials are all governed by your concentration gradients, right? Nothing's at equilibrium. So we have compartments, right? Compartments that have more ions in them than others. And so when we open up channels, these ions like to go down their concentration gradient. So they go from areas of high concentration to areas of low concentration. All right. In regards to an action potential, we have sodium. The compartment outside the cell is heavy on sodium. And that will allow, once we open up sodium gated channels, that'll allow sodium to come from outside to inside. All right. And that allows the membrane potential to rise because it hangs out around -70, -80. And then eventually it'll top out at +20, +30 millivolts. All right. And then once we're at the top of the action potential, the potassium channels open, allows potassium to move out of the cell, right? And that brings the membrane potential back down, back into the negative side. And then it kind of does this hyperpolarization and then it levels out. Now, the question that I've asked other students before is that neurons are not like one of these cell types that once it kind of blows its load, it dies out. Okay, it is meant to recycle, to get these ions back out and reestablish these concentration gradients once they go to equilibrium. Because once we fire an action potential, we have all this stuff coming in and going out, and eventually we'll reach an equilibrium where nothing moves at all. And we don't want that. We want concentration gradients. So once the neuron comes, fires its action potential, how does it recycle? How does it reset? How does it get sodium back out and put potassium back in? What's that answer? Does anybody know the answer to that? What is that concept? If we don't know, we got to say something. I just can't have silence. So the question is when we have neurons that fire an action potential, what is the concept? What is the device that resets these concentration gradients? What kicks sodium back out and allows potassium to come back in? Repolarization, at that point, sodium's already in the cell and potassium's out of the cell. All right. So we still have this hyperpolarization that kind of resets the cell. Yeah, we can, Cassie. All you have to do is just tell me to post it, and I'll try to post it. Um, so I can't waste too much time because we have a lot to carry. So this is a cornerstone of physiology, and it's the sodium potassium pump. Okay, it's the sodium potassium ATPase pump that will is the essential to life. And what I mean by that is it's such a little thing, but it's such a big thing because it will reset the cells. It resets the neurons. It uses ATP to pump sodium out and pump potassium back in. That's how we kind of recoil and reset the concentration gradients. All right, this is something we want to understand. All right, you will likely get a handful of questions on the sodium potassium pump as well as the action potential. All right. Um, so do we understand that part? Do we have to go further into the sodium potassium pump? Because I think now's the time to do it. I mean, let's at least get something out of Spotlight tonight. Yeah, sure, Cassie. So when we have a depolarization, a repolarization, and a hyperpolarization, so that means we fired an action potential. We fired an action potential. The signal has already gone on to the next neuron, and now this neuron that just fired the action potential has to reset. Okay, because it's going to have another, it's going to have another signal come down the line, and it has to be ready to carry out that voltage change. So what it does is that it uses its ATPase pump. And what this is, ATPase. Okay. And what that is that this is an enzyme. The ACE is an enzyme that uses ATP to pump sodium out to pump 3 sodiums out for every 2 potassiums in. Okay. Pump 3 potassiums out for every 2 potassiums in. That's usually a question. And so what happens is that may suggest, like, a question could be, well, why is the cell at a negative resting membrane potential? Or excuse me, why is the resting membrane potential negative? Okay. And the answer to that is because the ATPase pump, it pumps 3 out for every 2 in. So we have a net negative loss, a net negative 1 cation loss. Cations, if you may know, are positive electrolytes like K plus, Na plus, right? They're missing an electron, and that allows them to bump right, to become a cation. So if we're losing 3 cations and we're only keeping 2, that means we're having net negative 1 loss. That's why the resting membrane potential of neurons is around negative 70, negative 80 millivolts. All right. And how we know that is that we stick an electrode in there and we kind of measure it. It's like a needle, and we can measure the current or the voltage going on in that cell. And then when it gets excited, that's an action potential, and you'll see the spike in membrane potential, which is really just following the voltage change, right? And that's why we need to study the different stages of the action potential: depolarization, repolarization, and then the hyperpolarization. What that really is the sodium potassium pump um, resetting the cell for the next signal. So I hope that makes sense. Let me know if we're a bit vague on that, or if we need to dive in a little bit more, or if we're okay. So if depolarization is blocked, so what that is the fact that sodium is not coming into the cell. Sodium's not coming into the cell. So that means that the sodium pumps are not open. So sodium does not come into the cell. So therefore, when sodium does not come into the cell, cations are not coming in the cell, and then things don't rise up. So they stay. And eventually it'll hit like a threshold. It's called the absolute threshold, where it becomes like a true action potential, which means it's an all or none event. Okay, and we need sodium to come into the cell, to rise the membrane potential to maybe like -20, -30 millivolts, until it hits that threshold, and then it definitely will carry out an action potential. And frankly, if depolarization is blocked, like in cardiac cells, then we die. I mean, that's exactly what a heartbeat is, essentially. So if you were to block depolarization in the cardiac myocyte, cardiac muscle cell, there will be no electrical conduction, no contraction of the heart. Any other questions? Yeah. Well, I hope it does. It's when we start talking about Bio 139 stuff, it can get kind of cool. Any other questions on action potential? All right. So what about muscle contraction, muscle relaxation? Do we know anything about that? What do we know? Maybe I should say that. What do we know? All right. So I can explain. I'll just explain at this point. So when we have muscle contraction, muscle relaxation, what's really happening is that we are allowing our muscles to contract, to relax. We can control that, right? Well, there's two things that really control muscle contraction, muscle relaxation, and that is calcium and the role of myosin and actin binding. So there's actually two sides to this story. Okay. One side is the fact where once we have calcium that flows into the muscle, all right, and through T-tubules, they will bind to certain spots in the muscle, and this kind of starts the contraction process. So before we get there, we kind of need to talk about the anatomy part, okay, of the muscle. Does anybody know anything about the anatomy part of the muscle? Like, what do we know that how is the muscle made up? Yeah, Jan, that's a good idea. So that's a good start. So let's dive in a bit deeper, right? So when we have skeletal, cardiac, and smooth, when we're talking about like the building blocks of a muscle, what are we really referring to? We have the sarcomere, right? The myofibril, elastic fibers. Yeah, there's two things that we need to talk about. And if you remember anything about the sliding filament theory, yeah, we're getting close. If tight junctions, that's more cardiac, yeah, right? We're knocking the rust off a bit. So what about the sliding filament theory? What do we remember about that? What is the two components of the sliding filament theory? Like this is actual like muscle tissue. You guys may be overthinking it. Let's like zoom out a bit. Not so small. So it's the myosin thick filaments. Yeah, the myosin thick filaments and the actin thin filaments. So that makes up the sliding filament theory. Okay. The sliding filament theory is basically where the myosin here and the actin here. Um, that's all right. I think I'm follow you. What happens here is that they slide. Okay. This creates the tension. The myosin, which has a myosin head, we'll talk about that next, will bind to actin and kind of slide. They slide closer to each other. So if you've ever seen somebody flex their bicep, do the big, and you see like this big bulging muscle or whatever, what that is that that's the muscle that's shortening. Those are the sarcomeres that are shortening because the myosin and the actin are pulling towards each other. And there's so many of them that they have nowhere else to go but up. And that's a sign of a strong person, right? Is when we have these large muscle masses that bulge out, and that's that is that's something that really explains the sliding filament theory very well. So we have to kind of dive in a bit deeper and understand how that works, how we can control that, right? Because that's how we can contract a muscle, but we also relax a muscle. So this is kind of when we have to go back to calcium. Okay. So when we know about actin thin filaments, well, around actin thin filaments is a protein. I think of it as like a Twizzler or like a piece of rope that kind of intertwines, coils around actin, and it's called tropomyosin. And tropomyosin just so happens to have binding sites for calcium. So once you may recall, an action potential comes down, it releases calcium from the sarcoplasmic reticulum in the muscle. Like Lauren said, that releases into the T tubules. The T tubules are like highways for calcium. It kind of disperses the calcium very fast throughout the muscle because, when we want contraction, we want it like that. So once the calcium binds to the tropomyosin, we're getting there. Yes. Yeah. Well, Lauren, you read my mind. So, so what happens, as Lauren said, it causes a conformational change, right? And that unveils troponin, which just so happens to be the binding site for myosin heads. Okay. So when we have troponin that's unveiled to the myosin heads, that is what the myosin heads bind to. That creates the tension. And I've asked this question in the past, and I'll ask you guys. So some of you all who probably attended the muscle contraction relaxation spotlights, do we know the blood test that is ordered for a myocardial infarction, otherwise known as a heart attack? Like, how do we work those up? Yeah, we measure troponin. That's what it is, Cassie. Because if you think about it, troponin is very specific to the heart. Okay, it's the only place where we can find troponin. So if we have a myocardial infarction or a heart attack. If you understand what a heart attack is, you would know that it's a blockage, right? Where we have a lack of oxygen getting to some tissue, lack of blood, oxygen, things die off. Maybe not die off, things become damaged, okay? And when tissue becomes damaged, troponin can be released into the bloodstream, right? So then you go get your blood drawn, and they take it, send it to the lab, and then they realize, oh, well, you have an elevated troponin. This means that you've likely had some kind of cardiac damage over the past 8 hours, 4 to 8 hours, really. So that's why troponin is critical, right? It's one of the first things that show up to indicate there's been cardiac damage, likely done by a heart, likely from a heart attack. Sorry, couldn't get that out. So that's why that's why troponin is such a big deal, huge deal. Is that. So that's basically what happens when we have myosin contraction, or excuse me, muscle contraction. Now, there's another thing that we can control too, and that is the myosin heads. And this is the best way for me to explain it, is that the myosin heads really have, like, if you, this is how I demonstrate them, and the book is similar to my demonstration. I'm not too far off. But the myosin thick filament has a myosin head. So I try to call this the myosin filament, and then this is the myosin head. And it kind of goes up and down. It has two conformational changes. There's active state and inactive state. So inactive means it can't bind anything. It's not going to bind any kind of actin or troponin. However, when we have ADP bound to it, adenosine diphosphate bound to it, it's cocked down, otherwise known as it's an active form. Active, not inactive, active. And that means that it's ready to go find actin and create tension, right? That's kind of important. So when it's an inactive form, that means the ADP will convert to ATP. All right, adenosine triphosphate, really, when it's bound to the myosin head, means that it's in an inactive state. However, when that ATP becomes hydrolyzed to ADP, now it is ready to go in its active form. This is another way how we can control muscle contraction, muscle relaxation. It's another reason how we explain rigor mortis. Does anybody remember during my muscle spotlights what rigor mortis is? Yeah, it's stiff muscles. So what this is that when we have rigor mortis, that means that the myosin head is really engaged into the actin filament, okay? And the purpose of that really is that means the muscle remains stiff. We've all seen this on the side of the road. It's probably post-mortem, 24 to 36 hours later, depending on the temperature outside. If it's a hotter temperature, then likely it'll speed up the process, and we'll reach rigor mortis much faster. But the reason why rigor mortis develops is because all the ATP in the body is used up, right? Yes, we've passed away, but some things still may be ticking or metabolizing until eventually all the ATP will be hard to come by, and then it's no more. So if you remember, you might recall that ADP is what really activates the myosin head to bind to actin. And for the myosin head to relax or become uncocked or become in an inactive state, it has to have ATP bound to it. Well, if there's no more ATP bound because, we're no longer breathing or metabolizing, really, well, we're no longer making ATP, it uses all that up. So myosin remains in the active form, causing stiff muscles, like to the point you can't even bend them. And that's really, it's a phenomenon called rigor mortis. This is how we can understand time of death. We back that up. We can give a time of death between this time and this time. Very, very interesting. It kind of meets muscles with metabolism and criminology, I think is what they call it. Criminology. I'm not sure if that's a word. I might have just made that up. So that's a big one. So muscle contraction, muscle relaxation is a big one. I would definitely go over that, go over action potentials. Sympathetic, parasympathetic nervous system, we beat that one up pretty hard. I would definitely review that. And then a lot of the nervous system. Okay, nervous system is a big one. My exam for my students pretty much is chapter 12 and chapter 15, and all nervous system, glial cells. Does anybody know the difference between Schwann cells and oligodendrocytes? Do we have any ideas? So oligodendrocytes and Schwann cells make up the myelin. Yeah, Schwann cells are around the peripheral nervous system axon. Okay. Um, Usually you'll have one Schwann cell for every neuron. So some questions tend to show up on exams that um, Schwann cells are the predominantly for the peripheral nervous system, whereas oligodendrocytes are predominantly for the central nervous system. And oligodendrocytes actually will myelinate multiple neurons. Because if you think about it, the brain is such a compact space, we don't have room for an oligodendrocyte for every neuron. We just don't. It has to be an oligodendrocyte for lots of them. And both of them make myelin, right? Both of them are glial cells. You just have to understand where they go. Okay, who is for which one's for peripheral, which one's for central. Those are always a question that tends to get asked. So that's a big one. Understanding the neuron anatomy, astrocytes, gliocytes, blood-brain barrier with ependymal cells. Okay, I would definitely go over that. A little bit of neurotransmitters, anything that has to do with muscles talking to each other, that's likely going to be acetylcholine. All right, so I would go over acetylcholine, dopamine, serotonin, understand those, understand an EPSP versus an IPSP. And I'm not trying to blow your tops off, but that's an excitatory potential, something, something, and then you have an inhibitory potential. Basically, what that is that those are just, they're not action potentials. They're just little blips of membrane potential, right? That sometimes they can summate to an action potential, but it's everything less than an action potential. And action potential really doesn't become an action potential until that membrane potential hits -20, -30. If you have something that's like kind of going squiggling up and down from like -70 to -50, -60, those are really considered either IPSPs or EPSPs. So I would go over temporal summation and spatial summation. Those are definitely big concepts to go over in nervous system physiology. No, I thought it is, Jan. I think you're right. I'm sorry if I misspoke. The troponin on the actin. Maybe I was just saying directly to actin, but if I wanted to clean that up, then I would say that troponin is the bonding site on the actin filament. I hope that answers your question. Okay, cool. Yeah, the myosin head binds to troponin, which is the binding site on the actin. Okay. So the autonomic nervous system, we kind of touched on sympathetic and parasympathetic. We talked about that fairly extensively before Thanksgiving, in the first part, probably from like Thanksgiving up to probably from Halloween up to Thanksgiving, was a lot of sympathetic and parasympathetic autonomic nervous system stuff. So, that's fight or flight. That is rest and digest. Okay. Definitely would go back and review those. And what you can't forget about that I tend to skip over is the anatomy stuff. Okay. Memorizing the bones, memorizing the muscles. A lot of that's just, like I said, it's memorization. There's really no conceptual stories to that. There's nothing very fun about that. That's the dry portion of this class. You won't see a lot of that in Bio 139, but you still have to know about it. I mean, you are going to have to chart about that stuff, so that it is important to know. But I've your colleagues have mentioned it, and I've kind of endorsed it at this point, and I've used it when I was a student. I mean, Quizlet does the deal. It's already pre-made flashcards that you can flip through. Or if you go back to what I told everybody on day one, is to write it out. Write out your notes. That helps you remember it. So I think those are crucial. Everybody's different, Cassie. I mean, if you're one of mine, I have like 88, 86 questions. One section has 84, the other section has 86. So if you're one of my students, that's what it is, and that's all. I think I put that in the notes when you can click on the exams and see what they are. 84 minutes or 86 minutes, you get a minute a question, which in my opinion is quite a bit. That's a lot of time, especially if you're prepared. And I threw in some true false in there, in case people kind of get behind, they could click on true false and move along. Since a lot of my sections are online, we have to watch out for cheating. Yeah, okay, you got Dr. McCain. Dr. McCain will do something completely different than me. You can always ask her. It may be in the syllabus too, by the way. Okay, any other questions? Seems like we're a bit quiet tonight, which either tells me that we're comfortable on some things, and this is, we're just kind of reinforcing some stuff, or we're not, we're distracted by something else. So if we don't have any other concepts, yeah, go ahead, Janice. Yeah, Cassie, we can. It's going to take a minute. You're going to have to, do you know where I am on YouTube? Okay. Well, you'll have to find me on YouTube because I loaded up to the channel. And I only put these up when students ask. Okay. I think if you search, I don't know what it is either. I mean, you'll see some stuff in there from previous semesters. If you just search Bio 137 Spotlight, then I think you'll find the stuff. Um, so I would, so what has to happen is that once this uploads to the BCTC site, then I can download it and then upload it to YouTube. So that takes time, and especially coming up on like an hour, um, it's not, it's going to take some time. So um, I'll get it up to you definitely, hopefully before midnight, if not 11:30 ish. Well, I don't know. Probably no, probably. Sorry, probably 11. Um, okay, that's cool. I'll get it up. Promise. Um, I have you have any good tips for me to prepare for class? Yeah, Janice, just stay on top of it. This class is covers a lot of material. It is an introductory level class. I recommend going to spotlight sessions as much as possible, and then coming to spotlight sessions with concepts to ask the instructor to go over. Um, Typically, when we have good spotlights, folks come in with things they want to talk about, and then we can spend an hour to an hour and 15 minutes talking about stuff. Um, that's kind of what they're made for. Yeah, it's something that you want to revisit and you want to take notes on. You want to rewrite your notes. Unfortunately, I don't think I'm teaching anybody 137. I didn't get any of those assignments for next semester. But you know, you can always email me if you need to, if you need any help. Okay. I guess did I? No, not for BCTC. I'm teaching it for other KCTCS campuses, but not for BCTC. When they offered classes assignments out, things went so fast, which I'm not sure why, because I've taught two or three Bio 137 sections, two or three Bio 139 sections a semester, but I guess they've hired so many other adjunct instructors that it was kind of like a free for all, and I don't think I was not awarded any Bio 137s or 139s, unfortunately. I think I'm teaching 112. Which is, it'll be new for me, but it's a bit of a bummer. Okay. Well, it says here I have one. Well, thank you, thank you. I think it says here I have one other chat, but I can't see it. That's weird. Okay. Well, I hope I responded to everybody's chat. I'm not sure what happened. Um, so no, Dr. McCain does the other spotlights. She does the 12 o'clock spotlights. I think I am doing spotlight. I think I'm doing spotlights next year, next semester. I think I am. And I'm usually I'm the late person. So, 8 or 9 o'clock, Monday through Thursday. If you want to sign up for spotlights, I hope that they'll bring me back for 137 spotlights. I've kind of done this since its conception. I was one of the first people that kind of helped design the spotlights and figure out what we wanted to cover. And we're still tweaking it as we go. I've asked for next semester all you all be on camera. So we'll have to see how that goes down. I doubt I'll get it, but I think it'll help with less distraction. So that'll be something to look forward to. you may not like me as much. Well, good, Cassie. I'm glad you said that. That's good. Um, I'm glad when students say that, because this has all kind of come out of our heads to figure out how do we help folks during COVID, and kind of have like a recitation is kind of what I've always treated it. So I don't know if you can find them much on Janice. When I post my spotlights, it's usually because students have asked. So I don't post every spotlight session, and some of them are outdated. If you want to go onto my YouTube account, you'll see some previous spotlights that I've done over the past, but I'm not sure if they would help you as much. You really need to go into like lectures and stuff like that. Okay, cool. Well, I mean, that's the point. That's the point. It's helpful when folks come in and they are soft in something, like action potentials, okay? Or they're soft in a concept, and I can explain it and try to apply it to a way. Like last night we talked about what happens when we faint. We talked about the parasympathetic and the sympathetic nervous system, and how that, I mean, I can explain it real quick, but when we faint, what happens is that somebody has scared us, right? So all of a sudden, if you know anything about fight or flight, either means you see a threatening stimulus, you're either wired to run from it or you're going to fight it. Okay. Yeah. Well, we'll have to talk about that too, Jen. We'll talk about that next. The test taking skills is something that is a whole nother animal. We'll talk about that next. To finish up this concept, um, what happens is that yes, we get scared, and then the parasympathetic nervous system actually will overcompensate to make sure nothing gets damaged, because the stimulus has been so strong. The sympathetic nervous system like goes boom, like way up. All right. Well, then the parasympathetic nervous system will overshoot that. Okay, and it will dilate your vessels so much, so fast, that it literally drops your blood pressure like that, and you faint. You'll come back. You'll come back a couple seconds or whatever for your body to kind of equilibrate or compensate. I think equilibrate's the better word there, and then you'll respond. So yeah, that when I can apply real life things to Bio 137, I think students can figure, can really connect the dots and see why we learn this stuff, why we care about troponin. Um, I can't relate everything to bones and ligaments and stuff like that. Some of that's just memorization, but I certainly can try. A couple other things here. I heard Bio 137 is a challenging class, but I will be attending any available spotlights from now on. Thank you. Okay. Well, this is the last one of the semester. So you'll, because we're going into finals week next week, and I'm Monday through Thursday. I'm not sure. Now, Dr. McCain may have one tomorrow around noon. You'll have to check. But definitely picking up next semester. You'll hear a lot about spotlight sessions in class, and I do encourage you to use those and bring material to work on. That makes things a lot easier. Yeah, Gage, to answer, I'm sure I just answered your question, right? We're going into finals week next week. This is the last one for me. It's kind of bittersweet. So I hope to be back next semester to do more spotlights. So I'll just have to, I don't know, I'll have to figure that out. I think I will be, but it's, when you're adjunct, nothing's guaranteed. Okay. It's pretty difficult from my perspective, especially since my lab professor for bio. Oh yeah. Okay. Who is it? Just curious, Cassie. If you don't want to mention it, that's fine. But I'm always interested to see where students struggle with what professors. Okay. See you later, Lauren. Oh, yeah. Well, I hate that. Maybe that I'm sure everybody. It's hard for everybody to relate to all students. I'm sure I have my critics out there in my class. Um, I get some hate mail from time to time, but I understand. Get on. I think just my advice is try to do your research and find out who's good and who everybody likes, and kind of go from there. But yeah, I can understand. There's been some challenging ones out there in the past, and certainly now. Um, is the finals everything we learned? Yeah, I think they are, Jan. I mean, everybody's different. My students is chapter 12 and chapter 15, where some people are cumulative. So I would definitely check your syllabus. Um, all right. Any other questions before we break for the evening? Yeah, Mr. Scott Davis is very good. Very good. I'd say he's probably better than me. He's been doing it a long time. He gives a damn. Um, he may be one of the better assets BCTC has, and he's helped me out when I started out. Yeah, yeah, he helped me when I first started out on some things, and he even gave me some guidance on some of my lectures when I first started out. So yeah, I definitely hitch my wagon to Mr. Davis. That's good. Well, that's good news. Always good news. Well, we like to see students improve, even if sometimes it takes some time, a couple passes, but we do like to see folks get better. So you just got to keep trying. You can't quit. Yeah, I definitely. All right, guys. Any concepts? Are we good? Any questions? Oh, Jan, about your major test, a lot of that's going to be time. That's going to be preparing for the material, being comfortable with material, rewriting your notes, I think, and really watching your time management. Okay. I think a lot of that students run into with time management and being distracted or something along those lines. I would definitely recommend that. Yeah, thank you, Cassie. I will. I'm going to try to get that up on YouTube here in about maybe half hour, 40 minutes, however long it takes the computer to do it. So be on the lookout for that. And guys, if if you get in a pinch, you got my email. Let me know. And if I don't see you, enjoy the holidays. Happy Hanukkah, Happy Kwanzaa, Happy Christmas, all that stuff. And thank you, Janice. Very kind of you. Always appreciate the positive feedback. Lord knows sometimes it's few and far between. So I do thank you. And Jan, I think you're doing great. Just keep plugging. I do recommend writing down your notes. It's more time consuming, but you can code it in here. Yeah, you're welcome, Travis. Thank you. Thank you, Hannah. Hiya. I think I'm hoping I'm pronouncing your name properly. You're welcome. Um, okay, guys. All right. Well, I'm just an email away. All right. So good luck on the exams. And afterwards, have a beer and relax and regroup, reset for next semester. All right. And You'll know where I'll be. Hopefully, I'll see you guys next semester in Spotlight. Enjoy the rest of your evening. Good night.